Pipe bending. Unroll the copper tube. Measure the required length with the help of a steel rule. A mark is made on the copper tube. The tube is held on a wheel cutter. The hand grip of the cutter is rotated so that the cutting tool advances and touches the copper tube at the mark we made. Few rotations of the cutter will make an impression on the tube. The process is repeated until the copper tube is of measured length separated from the roll. Pipe bending can be done with the help of a pipe cutter. In the bender, there is a central wheel. Graduations are there in this wheel so that the handle can be turned at any angle from 0 degrees to 180 degrees. The tube is clamped on the bender with the help of the clamp provided at the left handle of the bender. Mark is made at the required angle. The right handle of the bender is moved towards the copper tube so that the tube is held gently between the right handle and the central wheel. The tube is bent till the mark on the tube coincides with the required graduations on the wheel. Thus, the tube is bended to the required angle. Dear folks, we are about to learn an interesting metal joining process, that is welding. Welding is an indispensable method widely used in all types of industries. Shall we learn what is welding?
This welding is broadly classified into two methods, namely fusion welding and pressure welding. In fusion welding, the most widely used applications are the shielded metal arc welding, gas tungsten arc welding, gas metal arc welding, and submerged arc welding. Here we shall study shielded metal arc welding, which is the most versatile and commonly used process in the fabrication industry. Now, what is shielded metal arc welding? It is having a shielding with the help of a flux coating. That is why it is called shielded metal arc welding. It is an arc welding where an arc has to be created for heating the material, for which the welder will have to take the electrode close to the job and he has to withdraw by a mm or so. In the process, the arc is initiated. The flux acts as the shield, thus not allowing the atmospheric air to contaminate the weld pool, and hence the name shielded metal arc welding.
The power sources used for shielded metal arc welding are AC-DC equipments, namely AC transformer, DC generator, AC to DC rectifier. These equipments transmit electrical energy to the workpiece and convert the same into heat for melting the ends of the metal. We use both AC and DC power sources for welding. For good quality welding, we always prefer DC power source. Even for continuous welding, we use the direct current power source. This one is called the rectifier. It was being used in the earlier days. These days, as it is not absolutely rectifying the direct current, we have to go for a generator like this one. This particular equipment is used for converting a high voltage, low current capability of the power into a low voltage, high current capability. Generally, welding is done between 60 and 160 amps in the shield metal arc welding. This is an inverter-based equipment. The equipment is very handy and portable. The welder can take it comfortably to any place and weld. It also has a very low power consumption, resulting in a lot of power saving. Let us know the main tools and accessories used in fabrication welding. They are the bench vise, welding cable, earthing cable, welding holder, welding helmet, welding regulator, chipping hammer, chisel, wire brush, hacksaw blade, hand gloves, grinding or cutting machines, grinding or cutting wheels, leg guard. This is bench vise, which is commonly used in workshops. Vises are used for holding workpieces. They are available in different types. A bench vise is made of cast iron or cast steel. It is used to hold work while preparing the edges of sheets plates and pipes by chiseling, hacksawing and filing. The welding cable's end is always connected to the welding holder. This holder is used to hold the electrode in its jaws. It is made up of copper or copper alloys, which have very high electrical conductivity. Now, in order to feed the electrode, a holder is a must. A major portion of the holder is made up of wood. This wood is an insulating material. If there is any electric leakage, it may save the welder from electrical shock. Earth cable is another important cable. It is an important connection for welding. This is an important equipment connected to the welding machine. This is called welding regulator. The welder has got graduations from 60 amperes, 80 amperes, 100 amperes and so on. During the course of welding, the regulator is used to control both the current and voltage. This regulator is important to do the different positions of welding. Welder helmet is a safety and a protective equipment used by the welder during welding. This has two components, the white glass and black glass. A white glass is basically used to protect the black glass from spatters during the welding. And the black glass prevents the ultraviolet rays that emit during welding and protects the eyes of the welder from being injured. This is a GQ4 grinding machine. We use this machine to remove the slag that is coming from welding. We have to remove the slag continuously. For this purpose, we use a 4-inch grinding wheel. AG5 machine is used for cutting. Cutting wheel machine is a heavy-duty machine. We use this machine for cutting mostly very high abrasive tools. These are all some of the wheels and discs that we use in this machine. So, this is a typical grinding tool. The grinding wheels are made up of abrasives. This is a cut-off wheel used and grinding wheel for cutting purpose. This is a grinding wheel and both are 7-inch in diameter. The selection of the equipment depends on what you want to cut. Depending on the thickness, the RPM, the power in watts and so on, you can save time while cutting the huge amount of metal using the appropriate equipment. This is a grinder helmet used for protecting the eyes of wheels. A grinder will always use this helmet so that the metal particles do not get into the welder's eyes. The chisel is used for chipping operation for removing excess metal. Chipping hammer is used for removing the patters and also to clean the interpasses of the welded layer. This is a metallic brush. We have to clean the weld bead with this wire metallic brush. It cleans the welded surface from layer to layer. Electrodes are the sources of filler metal that are used to melt and join the ends of the base metal. Shall we know them? The three types of electrodes used in metal arc welding are cellulosic, rutile, basic. Let us know more about the types of electrodes, their uses and where they are applied. Cellulosic electrode coatings are made up of materials containing cellulose such as wood pulp and flour. The coating on these electrodes is very thin and the slag is easily removed from deposited welds. The coating produces high levels of hydrogen and is therefore not suitable for high-strength steels. Rutile electrodes are general-purpose electrodes having coatings based on titanium dioxide. These electrodes are widely used in the fabrication industry as they produce acceptable weld shape and the slag on deposited welds is easily removed. Strength of deposited welds is acceptable for most low-carbon steels, and the majority of the electrodes in this group are suitable for use in all positions. Basic or hydrogen-controlled electrode coatings are based on calcium fluoride or calcium carbonate. This type of electrode is suitable for welding high-strength steels without weld cracks and the coatings have to be dried. Electrodes, especially low hydrogen electrodes, need to be baked in equipment named as electrode baking oven. Electrodes are placed in trays and heated to 300 degrees centigrade for 2 hours to prevent or remove moisture entrapment in electrodes. After baking is completed, these electrodes are transferred to holding ovens which are maintained at a temperature of 150 degrees centigrade and used for welding at this temperature. There are 4 types of joints used in fabrication welding: lap joint, T-joint, corner joint, butt joint. Lap joints. In lap joints, one plate is placed parallel over the other plate with a lapping length as per requirements. T-joints. In T-joints, one plate is placed perpendicularly over the other plate lead to form a T-type of joint. Corner joints. In corner joints, one plate is placed perpendicular or at an angle to other plate with inside corner edges of plates are placed together. Butt joints. In butt joints, one plate is placed adjacent to the other plate with a small gap in between called root gap. Plate fillet weld position. Now let us study the welder's qualifications. This is very important because unlike other trades, here the welder has to be qualified enough according to the international standards. The basic requirement for the welder is to start with a fillet weld qualification. This 4 position, that is 1F, 2F, 3F, 4F is the most easiest and the most simplest of all to start welding. Now, in 45-degree tilt, the welder is going to weld in downhand position. Now, next position is called 2F. 2F is called horizontal position welding. Now, the weld axis is horizontal and electrode axis also horizontal position, and we are going to weld the joint like a fillet weld. So, this will be called 2F horizontal position fillet welding. Now the third position is called vertical up. Now this is a vertical joint where the electrode is kept at the bottom of the test piece and the welder is going to drag this vertical straight up by welding against the gravity. So this is called 3F position. "4F overhead position. In most of the project, the welder may weld something above and weld metal come against the gravity. The electrode is kept over the head like this and the welder tries to do this electrode manipulation. This is called 4F welding. Let us see the different positions involved in true welding. Flat position, horizontal position, vertical position, overhead position. Flat position. In flat position, welding object is below the welder and welding electrode is placed downwards while welding. Horizontal position. Now, in horizontal position, welding object is placed in the plane parallel to the welder and welding is carried on x-axis from left to right or vice versa. Vertical position. Vertical position in which the welding object is placed in the plane parallel to the welder and welding is done in y-axis, that is, from bottom to top. Overhead position. In overhead position, as the name indicates, welding object is placed over the head of the welder and in reverse to flat welding, electrode is placed vertically upwards during welding.